Here's another problem. This one's a little bit different. It's talking about the cost of constructing this box. So you have a rectangular box. Here's your constraint. Volume has to be 320 feet cubed. It's to be constructed with a square base. That's important, a square base on top. The cost per square foot at the bottom is going to be 15 cents. For the top, it'll be 10 cents. For the sides, it'll be 2.5 cents. What are the dimensions that will minimize the cost? Okay, so we have this time a lid. Okay, it says square, base, and top. So I don't know the dimensions, but I know they're the same. So I'll use X and X. Don't know the height, so we can use H or Y. Let's just use Y. We do know the cost per square foot of the top, the bottom, and the sides, and we want to minimize the cost. So then it's going to be area of the bottom times the cost per square foot plus area of the top times the cost per square foot plus the area of each side, and there are 4 of them that are the same, times the cost per the square feet. So cost will be equal to, the bottom will be X times X, so X squared times the cost per square foot is 0.15, plus the top, which again is X times X, so that's X squared, times the cost per square foot, which is 10 cents, plus 4 sides, area of each will be X times Y, times the cost per square foot, which is 0.025. Let's simplify this. So these two are like terms. 0.15, 0.10, that's 0.25 X squared. And then if I have 4 times 0.025, that's going to be 0.1. This is plus. So 0.1 or 0.10 times xy. Okay, this is good, but again, there are too many letters. I need just C's and hopefully X's. I want to get rid of the Y, which means we have to go up here and use this constraint. We have not made an equation for that. So volume for this box will be length times width times height. Length and width are both X, so X times Y, which is X squared times Y, which has to be 320. So let's go ahead and solve this for Y so that we can get Y in terms of X. So Y will be equal to 320 divided by X squared, which means up here in the cost function I can take that Y out and put the 320 over X squared in. Cost will be 0.25 X squared plus 0.10 X times 320 over X squared. Let's do a little simplifying in here. Cost will be equal to 0.25 X squared plus 0.10 times 320 will give me 32. This X will cancel with one of those, so 32 over X. Alright, then let's go ahead and do the first derivative. So we can do a first derivative test. C prime will be equal to 2 times 0.25 is 0.50 X. Again, think of this as 32 times X to the negative 1 power. So negative 1 times 32 is negative 32. And then the negative 1 minus 1 makes it negative 2, which sends the X back into the denominator as an X squared. Critical values, X can't be equal to 0. Again, makes absolutely no sense in the context of our problem, so we're going to ignore that. And then 0.50X minus 32 over X squared is equal to 0. Clear the denominator by multiplying all terms by X squared. 0.50 X times X squared is X cubed. X squareds would cancel in the next term, so minus 32 is equal to 0 times anything is 0. Add 32. And we're going to divide by 0.5. So dividing by 1/2 is the same thing as multiplying by its reciprocal, which is 2. So X cubed will be actually equal to 64. If we take the cube root of both sides, cube root of 64 is 4. So we're thinking this is probably going to be a 4 by 4 base. Let's go ahead and check to see if that's a local max or min value. We'll use 3 and 5 in our first derivative as test values. So in my first derivative, which is up here, if I use a 3.5 times 3 minus 32 over 3 squared, 0.5 times 3 would be 1.5, and 32 divided by 9 is going to be 2 point something. So this is going to be negative. So we are decreasing. On the left-hand side. If I put a 5 in there, 0.5 times 5 minus 32 over 5 squared, 0.5 times 5 is 2.5, and 32 divided by 25 is 1 point something. So 2 point something minus 1 point something will be a positive number. So we're going to be positive on the right-hand side, which means we're increasing. So I'm not really concerned with what the numbers are, I just need to know their sign. So if we go from decreasing to increasing, then we have found a local minimum value, and we want to minimize cost, so that's perfect. So far then, we knew that our base is going to be a 4 foot by 4 foot base. We need to figure in and use
320 divided by 4 squared, which is 16. 16 is going to go into 320 20 times. So a 4 by 4 by 20. Okay, so then y will be equal to 20 feet, and x will be equal to 4 feet. So our box dimensions will be 4 foot by 4 foot by 20 feet to minimize our cost. And since it didn't ask us for the actual cost, we actually do not have to go back up to this formula and plug it in and compute it. All right.